Today in this session we are going to discuss about fuel cell. So it will be introduction to fuel cell, but before we start with this, let me, so this is what that I am going to present today. So electrical power source, why fuel cell, and different aspects of fuel cell. But before I start, let me ask you the very big question, that is, why electrical power and why we are using electrical appliances equipment. So anybody can answer this. Why? First question is, why electrical power? Why? There are so many powers are available, right? So power means you can drive using, let's say, diesel engine you can drive, let's say car. Forget about anything else, let's car. So we can drive car using IC engine, you can drive car using electrical motor. Why we prefer for electrical thing? What is the answer to this? You people are from electrical background. So if I ask, or if somebody asks you, let's say any random person asks you this question, that why electrical power, why we are prefer this, what would be your answer? Achha, let's say for car, IC engine based cars are very much suitable and it's a state of art, right? But still we are moving towards EVs, right? This is one. So it is not like that it is easily, means for a specific application we can use it. Okay, so any other reason? Huh? Pollution, when you are generating electrical power, somebody is generating somewhere, right? So you are using this AC, so somewhere coal is burnt and power is generated. Okay, so pollution is there, not here, but pollution is definitely there. What else? What is the major reason? Do you know diesel locomotives that we have in India, because I have seen in India, those are actually electrical in nature. Do you know that? The diesel engine runs an electrical generator, and that generator produces electrical power and it runs electrical motor, and that electric motor runs the train. Okay, so if you can, so that's the first question that I want to ask you. I remember last year I saw one video, I don't remember whether it was on YouTube or whether it was on WhatsApp. I saw one video where a person wakes up early in the morning. Okay, now every equipment or appliance that he is using at home is powered by not electrical, powered by some, let's say, some fuel which is emitting some gas. Okay, so he is using trimmer, that is some diesel powered trimmer, it is emitting gas. He is using toothbrush, electrical toothbrushes are there, right? So using that diesel or petrol powered toothbrush. Okay, those kind of thing. Oven is there, there is a chimney from where the exhaust is coming out. So every equipment is not electrical, but so that is also feasible, right? If we think about, let's say that emission, let's say forget about emission, but it is feasible, right? But still we are preferring electrical power. What is the reason for that? That I want to know. Transferable to long distance. Okay, that is one. But now we are not relying on conventional power generation. We are relying now on distributed power generation. So that also out. So anyone from online participants, anybody can answer me this? Why electrical power? Why electrical power? What is the meaning?
We can easily control the electrical parameters compared to other form of energy.
That's a very good point. That's a electrical. The controllability of electrical parameters are much more what I should say, it's you have more degree of freedom than the mechanical thing. That is one point. That is correct. Another thing.
The response is very quick.
Response, if it is a mechanical system, electrical system cannot make your system quick. Let's say you want your car to be accelerated in 10 seconds. If it is IC engine based vehicle and it's electric engine based vehicle, both will give you 10 seconds. Okay, so electrical responses are faster, but not mechanical. Ultimately using for mechanical thing. Okay, so you relying on liquor. Okay, electrical system efficiency are much more than mechanical system efficiency. That is one of the major reason. Okay, Another reason that this is the most important reason, because what we are doing now, we are trying to harvesting what? Renewable energy, right? So now renewable energy you are converting, so you are generating power, so that power is electrical power which can be easily stored. You can easily store in the form of what? In the form of, let's say, battery energy storage. You have this inductor, superconducting inductors, there you can store the electrical energy. So storing of electrical energy, the efficiency of electrical energy is superior, control of electrical energy is superior. These are the major reason because of which we are using electrical power and we are looking for electrical power, right? Now next question is, what would be the, so now you need electrical power, right? So you are looking for what? You are looking for electrical source, electrical power source. Okay. Now we as an electrical engineer, if some random person comes and give us a power source, let's have it and you power up your home. Let's say, forget about industry and other thing. Let's say that person is giving you an electrical source for your home. So what are the things that we will look into, that whether it is suitable for you or not? How will you judge? What are the parameters that we will look into? Why I am asking these questions? Because conventional power system was there. Now we are coming up with PV, wind, fuel cell, battery. There are geothermal, some micro hydro, mini hydro power plants are there. How to choose which power source will be suitable for which application? Because why I am asking this question, because it's not academic research. Whatever you do in academics is for you do the research, because you cannot do something immediately on the practical field. You have to do some research, you get some knowledge, and then you can implement it for the industry. So let's say if a power source is given to you, if it is not practical, then it is not acceptable. So if some power source is given to you, how will you understand whether that power source is acceptable or not? So what are the parameters that we will look into? What parameters? Anything you can answer. Let's say, what will you look into? Why the power source should have what?
Nature of the source.
Nature of the source in the sense DC or AC? Okay, DC AC. Okay, very good. 1 point. DC AC. That is one of the point. What else?
Output power, voltage and current.
Voltage level, current level. Very good. Yes.
Power density.
Power density means how much size and this volume. Correct. Absolutely correct. What else? Capacity, yes. Power rating, yes. What else it could be?
Whether it is environmental friendly or
yes, very good. Yes, correct. That is also a point. Whether emissions are limited or not, whether that emissions are acceptable to our environment or not. That is correct. Major points are coming up. Okay. What else? Why? Because we are going to talk about one power source. So let's see.
Also see whether it is supplying continuously or it is an intermittent source.
Absolutely. Very good point. Correct.
Protection schemes.
Protection schemes. Okay. Protection schemes. Right. That also will come. Yes. Anyone from online participants?
Electrical source is not available as such. What type of energy we have to use to convert into electrical energy? That is also very important to make electrical power source.
Okay. Okay. So let's say my point was, let's say somebody is giving you the power source, whatever be the input, the output of the source is electrical. So if that kind of source you have, so what could be the parameters that you will look into?
So can it be cost and reliability of the supply?
Absolutely, absolutely correct. Cost and reliability, absolutely. Yes. So most of the points are covered. Okay. So first thing that we should look into is the availability of that power. Let's say if it's a solar powered, if it is a solar power, at night you don't have power, right? So first thing, you need power 24 into 7. So if it is solar power, let's say the person is giving you, let's say solar, which is relying on sun, then you cannot accept that power. So you must have a battery backup with that, then only it is acceptable. Then is reliability. You bought it, you got it, you used for let's say 30 days and then it has damage, it is damaged. So that reliability is not there, so you cannot use that power as well. As you mentioned, size and weight, definitely. If for your home he or she is giving you a power source which is a size of your home, then you cannot accept. A generator, diesel generator size is there, and if you are going to take it, you cannot accept that, definitely. Cost, definitely cost. What are the three things that you need to look into? First is the installation cost, then second is the running cost, and third is the maintenance cost. All this cost matters a lot. Infrastructure cost like solar, wind, if you are going to see, infrastructure cost is more, maybe running cost is very low, but maintenance cost might be there. Let's say battery, the maintenance cost is high. Okay. Now emissions, as you mentioned, emissions, solar no emission, wind no emission, but there are diesel and other power plants which are having emissions. Now intermittency, if it is intermittency means let's say solar, wind and all, those are what? Those are weather dependent. Okay, it's we did experiment on solar for charging battery. I should not say EV battery, but we started with battery, and it was the solar panels were put on the direct sunlight, and it was varying like anything. Okay, so that is intermittence in nature. Durability, it has to withstand harsh weather condition. It might happen that you are putting this in a very, like one professor was mentioning that they have installed lots of solar, they installed a solar park, and they installed this PMSG, permanent magnet synchronous generator, where the generator magnets were deteriorated because of extreme humid condition. So magnets, he was mentioning that magnets becoming powder. Okay, so that means it is not having that durability, right? Durability under extreme condition, durability over the years. Now let's say a battery, if you have a battery at your home, what happens over the year means battery, now most of the home equipped with the inverters. So if you have an inverter at your home, inverter comes with battery. So when it comes to battery degrades, battery life degrades with time, state of health of a battery degrades. Okay, so those things that you need to look into. Now output, AC and DC. So you have to look into whether it is AC or DC output, and accordingly you have to make arrangements. Now whether it is a voltage source or whether it is a current source, that is also important. As you mentioned, protection will depend on, if it's a current source, you don't need any short circuit protection, or you need, it should not be, if it is a voltage source, short circuit protection should be there, open circuit will not be a problem. If it's a current source, the open circuit will be a problem, short circuit will not be a problem, right? So these are the things that you need to look into. Whenever you get a power from something, and then immediately you will think that okay, this is acceptable and we can use it. It is not like that. Okay. Also, I mentioned cost. So sometime the power sources which are feasible in nature, but because of cost we are not using. Now fuel cell. So hydrogen fuel cell, what it happens, there is a chemical reaction happens, and because of that there is a electrical energy, and there will be water and heat will be generated. It is abundant availability. Sometimes people say that it is renewable energy. It is not renewable energy, because it is H2 is availability is abundant. So that is why we don't think of that. It is like free energy. Now emission is almost zero. Okay, emission is almost zero and nearly zero carbon emission, and it's efficient. I should not say it is efficient. If I tell you that what is the efficiency of a power plant, if anybody can tell me the figure, 40%. It's very low. It is also around 40 to 50%. It is not highly efficient, but yes, efficiency is of the order of this, because there is a heat is also generating. Okay. Now, sometime we say that what is the emission of electric vehicle? What is the emission of electric vehicle? Emission of electric vehicle? Emission of electric vehicle is not zero. Okay, you cannot say. If you go and see the data sheet or a specification of any electric vehicle, you will see that it is not zero, but it is dependent on what is the emission that is generated by the power plant. So, what is the application? So, now it is, you can see it is, I remember, if I see here bus, I remember this bus. I remember long back in 2013, I think 15. In 2015, I was in the morning walk. Generally, I go outside, and this is NIT Rourkela campus. I was in my PhD institute. I went outside for a walk, morning walk. I saw a very big bus. Okay, very big bus, and that bus was a fuel cell bus. Okay, it was in 2014. And that bus was by some very renowned company from India. Okay, so you think that bus is that bus in 2015, either 15 or 16, I don't exactly remember the year. So if the bus is in 2016, maybe they started work 5 years back. So if I assume 5 years, so it is 2010. Okay, so there are industry who started working maybe 20 years back on this fuel cell and fuel cell vehicle. Even fuel cell vehicles are available. There are companies which are already launched fuel cell hybrid vehicles. Okay, so there are applications like transportation, fuel cell train, hydrogen train. Very soon India is going to test hydrogen trains. Cars are available, trucks are available, utility power supply. So there are fuel cell. We'll see the power rating of the fuel cell. There are fuel cell which are sufficient enough power generation which you can supply to the utility or connected to the grid as well. Okay, microgrid power supply. Here also you can fuel cell based microgrid you can think of as a distributed generation. Power supplies to residential commercial building, and also as an energy storage for off grid solutions. That I will talk about. Just one line I will tell you, understand why we are saying it is energy storage. Okay. And what is the difference between battery and fuel cell? If I say both are black box, so if I say if you want to compare with fuel cell and battery, the first thing that you can see into, fuel cell needs continuous power flow, and so it does not need any recharging or charging. Charging is not needed. So actually it is similar. What happens in battery, you charge the battery, it stores the energy, then delivers. Here in fuel cell, what happens? Continuously there is a flow of fuel, and it is continuously chemical reaction is going on, and continuously power generation is there. Okay, so hydrogen fuel cell we'll talk about. So this is very interesting point. At low temperature, operates at low temperature. What happens? Anything that operates at very high temperature, definitely its durability will go down. Right, at high temperature there will be deterioration of the equipments or parts that is attached with that fuel cell. Definitely it will deteriorate. So if it is on long run at high temperature, definitely its durability will go down. Hydrogen fuel cell operates at low temperature. So low temperature operation improves the durability of any source, not only fuel cell. So power quality also remains same in the sense that deterioration is less. So if you see battery, as I mentioned, battery, if we continuously, when you have inverter battery at your home, okay, do you know what is the most important point to save your battery? The two things that you need to maintain about battery. If you want to take care of your battery, what is the main thing that you need to take care of? Repetition of charging. Okay, fast charging and repetition of charging or discharging. means multiple time charging discharging will deteriorate a battery life. So that this is what here it is mentioned, that it is superior than battery because it is operating at low temperature and its power quality does not degrade over the time. Also it is tested at very extreme conditions. Okay, it's a lightweight unit, so durable than most of the batteries. That I fast refueling, that as I already mentioned, that battery has to charge, it takes long time to charge. It's not a home battery. If it's a battery energy storage, it's a very big battery, that if it is discharged, it will take lot of time, lot of current to charge it, and that's why here it is continuous, there is a flow, so it's no problem. So reliability reduces maintenance cost. Okay, so I talked about this storage. It acts as a storage. So what it says, that what it needs, I will explain in next slide. So if you can produce hydrogen, it will produce it will produce water. That water you can convert into hydrogen and oxygen, and that can be fed to the fuel cell, and it can generate power. So by using renewable energy you can do this, and hence this does not, it can be a sustainable solution. It can run standalone. You don't need any other power source to run it. So like that, it can be a power storage thing. Okay, scalability, this is also a very important factor. Okay, scalability. Let's say today what happens, what is scalability, let me explain you. What happens in my native place, beside my home there was a transformer. Okay, distribution transformer was there. Now that time the number of homes were less, and also the amount of power consumption was also less. That time barely 1 or 2 homes were having AC. Now almost every home is having AC, and almost every home, maybe multiple ACs are also there. So power has increased. So because of that, and also now number of homes are increased. So because of that, what they are doing is they have installed 2 more transformers. So because of that, the amount of space that you are going to get is take is more, right? So scalability, you are connecting them in parallel to increase the power level. So here the scalability is, here you have small power cells, and you connect them in series and parallel, and you can have big power in it, so that it can generate power at the desired output power level. So if you need more power, you can keep adding the power cells and to make more output power. That is called fuel cell stack. We'll come to that, fuel cell stack. Okay. Now this is here I will mention about how fuel cell module or fuel cell power cell, how it works. So what we have is, on one side there is a hydrogen flow, on one side there is a air flow. So actually what we need is, we need oxygen from air. So we need arrangement for that. So there is channel for hydrogen flow, there is a channel for air flow. Now when it comes, okay, this hydrogen has to be, this is one of the challenge that you have here. The hydrogen has to be very pure. Okay, 99.99% pure kind of hydrogen that you need, that is the fuel to this fuel cell. Now there is air flow, from air you have to extract oxygen. Okay, so these 2 layers are called gas diffusion layer. These are porous and conducting layer. Okay, porous means gas has to pass through it, and why electrical conducting, because electron has to pass through it. Okay, in both the cases electron has to pass through it, so that here you will see. So then what we have is microporous layer. The function of this is like coating. This is like a coating on the GDL, gas diffusion layer. 2 coatings will be there. The function of this is these are the 2 electrodes. It try to distribute this gas throughout the surface area. This 1 dimension I am showing, it is actually 2 dimension. The function of this microporous layer is to distribute the gas all throughout the electrode, so that this chemical reaction takes place properly. Now these are the electrode catalyst. So here, so these are the 2 electrodes, plus and minus, and this is the electrolyte. Okay, so how it will work, that I will come to that. So these are the two electrodes, plus and minus. Now let's see how it works. So hydrogen is coming, then oxygen is coming, and then, so what it does is, here the electrons leave this positive plate and it goes through the load. So hydrogen comes from here, and then this electron leaves from here and it passes. So there are two channels, one is through the electrolyte and one through the load. So electrolytes allows the positive ions only. So hydrogen passes through it, and then electron passes through, which is our need. Electron is not allowed to pass through that electrolyte, it passes through the load, and that's how we are getting the electrical power. So and then it comes in contact with oxygen, and then with the electrons are accumulated here, and then what we are getting here, then electricity we are generating, and then water and heat we are generating. So this is the process is going on inside a fuel cell unit, a fuel cell module. This process is going on. So hydrogen continuous, there is a flow of hydrogen, and continuously there is a flow of water. This is not water, it is hot air, so it is water vapor. Okay. So what happens? So the same thing that is mentioned here, power generation by combining H2 and O2 at the electrodes. So in H2 is split into H plus and E minus at anode, and H plus through the electrolyte membrane to reach cathode. In cathode it mixes with electron and oxygen to produce electricity, water and heat. Okay. It's an electrochemical process producing electricity continuously when your flow is continuous. But we'll see, it depends on how much electricity is produced, that depends on the flow of hydrogen as well, how it depends. So these are the two equations. Chemical reaction is taking place, and this is the energy which is utilized. So this mole converted into per mole, this kilojoule per mole is converted into heat and electricity. So if we take heat and electricity together, then its efficiency is more, but if we take only electricity, then its efficiency is low. So these are the equations. Okay. So here, from here, the thing that we need to look into, it is generating a voltage of 1.23 volt, okay, which is not sufficient. Even that is under open circuit condition. When you are loading anything that you load, the voltage comes down. This you must be knowing, because there will be some internal impedance, and when you increase current, definitely there will be a drop and there will be decay in the voltage as well. So this is the open circuit voltage, and therefore how it can be improved, that's why we talk about fuel cell stack. In fuel cell stack, so this voltage comes down to 0.7 volt. Okay, when you are loading the fuel cell, this voltage comes down, further it comes down. So we have to connect them in series and parallel. So single fuel cell voltage and current is not sufficient. So most of the practical applications. So 1.7 volt, what will you do? So for reasonable voltage, multiple fuel cell units connected in series parallel, so that is what I was talking about. You can scale it up. Okay, to necessary voltage and current level, you have to connect them in and make a fuel cell stack. So people will say that, okay, this is 1 kilowatt fuel cell stack of 24 volt or 30 volt or 48 volt, like that. This is called fuel cell stack. So generally it is not less than 50, it is more than 50. Okay, number of these are very thin. These are very thin, and you can connect them in parallel with bipolar plates. There are bipolar plates in between, because one cell is there and then another cell will come in contact with it. So you must have bipolar plates, so that you can connect them in series. Now efficiency of fuel cell. So if conventional power flow we can see here. So conventional power fuel flow is there. Let's say a conventional thermal power plant, if we see. So what happens? The fuel comes and then there is a combustion. From that we generate steam. That steam is rotating the steam turbine. The steam turbine is associated with a rotating generator. That generator is producing. So efficiency, every stage there is a loss. whenever there is a multiple number of stages, definitely your efficiency will come down. Why? Because if you, let's say 90% efficiency of one stage, so if you have 5 stages, so you multiply 0.9, 0.9, 0.9, so efficiency subsequently go down. Okay, but in fuel cell, if you say, so here you have only chemical energy and then it converts into electrical and thermal energy. So efficiency is 40 to 60% when you consider both electrical energy and thermal energy. Sometimes there is a need for co-energy, okay, co-energy generation. So you want electrical energy, you want thermal energy, you can use it, and means there you can utilize both heat and as well as the electrical energy. Now here you can see this is the characteristics voltage versus current density. Now you see here the voltage is coming down when you are loading, the voltage is coming down. So here ohmic region, it is almost linear. So resistance is constant. As you are increasing current, there will be a subsequent drop, and there the voltage from the fuel cell will come down. So this is the voltage of a fuel cell stack. So generally if you operate, let's say at 30 ampere, if you 30 ampere, so you will get 33 or something voltage. Okay, so this is how much wattage you will get then? 33 volt and 30 ampere, around 1 kilowatt. Okay, so 1 kilowatt fuel cell with 30 ampere output and 33 volt that you can use. Okay, now if you change the flow rate, if you change the flow rate, subsequently the voltage and the power level also changes. Okay, voltage and so if you see here, the fuel cell, the power, the flow rate, if we are changing, we can see here we have plotted this in MATLAB. In different papers you will see there is a significant difference, but this is plotted in MATLAB, and there we can see that the difference is not that significant, because for the presentation purpose we may show that there is a significant difference, but actually there is a difference. Okay, now because of this power difference, so you have to have what? You always have to follow the maximum power. It is like maximum power point tracking we do for what? We do for maximum power point tracking. Do you know? PV, then wind, then for hydropower plant, mini hydropower plant. Okay, so everywhere when there is a change in when there is a change in power with some input parameter, you have to track that point, the maximum point. So always you have to have something along with the power source, so that you can track the maximum. It is not like that you cannot generate power, but you need maximum power. You have to utilize the full power. That is why there is a need for maximum power point tracking. So these are the losses that we have mentioned here. These activation loss, ohmic region loss. So what are these losses? That let me explain you. So activation loss is majorly due to, it happens in the electrode surface. So slowness when reaction, it's a chemical reaction. When there is a slowness in chemical reaction, so you need some energy to speed up, so drive the electrons. So there is an activation loss. Ohmic loss is due to, there will be definitely, since there is a conducting path, nothing is, even if it is a superconducting coil, there is a resistance. You cannot avoid a resistance. You have to come with that. You have to work with that. So there will be definitely an inbuilt resistance will come into picture. Okay, since the output of a fuel cell is DC, so we are talking about resistance. Why we are not talking about inductance in that case? Inductance will be there, right? If it is a wire is there, definitely there will be a resistance, there will be an inductance. So why we not talk about inductance there?
Negligible there?
No, negligible may not be the reason. Okay, maybe it is negligible, but because of that, because we talk about steady state. Under steady state, an inductor behaves, when it is a DC circuit, under steady state it behaves like a short circuit. Okay. Okay. So other concentration losses and fuel crossover losses are there. Okay. So this is like if you have a model a battery, you have seen for battery also we do a modeling like that, capacitor and then resistor and all, and this model gives you because everything we have to model. Why we have to model? Because we need to know its dynamic performance. Because of that, we need to know anything we need to model. A transformer, we model it. Okay, a high frequency transformer, we model it. Every equipment we have to model in order to understand it, the behavior of it, and so that how closely we can relate its behavior using that model. This model may not be unique. This model is mentioned in this paper. There could be several other models. You can also come up with your model, so that it should be as close as possible. Because why I am telling this model, maybe this model is suitable, but it might happen that how we are calculating this R activation loss, R ohmic loss, R this mass transport related loss, this measurement or this estimation could be different in different method. Okay, so that is why you can have n number of models. Okay, now fuel cell rating. Okay, so here just I want to mention you, in fuel cell is a like PV also. It's like current is high, voltage is low. Okay, so when there is current is high, voltage is low. Okay, we'll come to that. Just let me just tell you one thing. So you can see here the only major thing that you need to look into, there are fuel cell system from 10 kilowatt, 2 kilowatt per cell is also available. Okay, there are multiple fuel cell suppliers are available. If you search over internet, there are suppliers. Okay, they can supply. So they can supply up to, there are fuel cell industries are supplying commercially available up to 250 kilowatt, and you can connect to the grid as well. They will provide the fuel cell stack and also will provide the necessary converter along with it. Okay, it's a ready-made solution. You install it, and one of the major thing is, one is there is no emission. Okay, let's say we have a diesel generator, as sir was mentioning, we have diesel generator at different parts of our campus. So there are emissions, there are sound coming from that thing. If you replace them with battery, what could be the disadvantage? We can, let's say same size box, we replace with battery box, multiple batteries connected in series, parallel, or whatever it. What could be the disadvantage? Battery, if it comes to battery. So definitely there will be a degradation of the battery, and you need a good maintenance of a battery. Now if you replace that thing with this thing, fuel cell, the first and foremost thing that you are going to have is its reliability is good, its efficiency is good. The third thing is its noise is very, very less, emission is not there. Okay, so it will be there of same size, but you will have these advantages. Okay, now fuel cell applications, where people are using fuel cell. We talk about application of fuel cell in microgrid in this GIAN course. But fuel cells, you can see here, fuel cells are already people have started using and also proposing for, let's say, primary backup for power generation, commercial and industrial buildings, residential applications. Now remote locations, okay, I remember somebody was mentioning that in some forest, okay, some research people see that some research person will be there who will be, let's say, going to Sundarban for, they are in research on different field, not electrical engineering, maybe on mangroves or something. They need power backup, definitely they need power backup. They cannot take what? Battery along with them. It's a heavy, right? It's a remote location. So you need a lightweight solution. So you can use this kind of thing. Okay. So for remote weather stations, right? So communication centers, rural area, remote research stations, you can use this kind of power backups. Large scale energy, so you can install at larger scale also. Automobiles are also there, definitely it is there, but these are power levels are less. But here the power levels are far more than when you are connecting to the grid. Distributed generation for microgrid application. Okay, emergency power supply. Now cogeneration, as I was talking about, so where you are both using both electrical energy as well as heat energy. So in that case, your efficiency is far more better than whatever a fuel cell when you are using for electrical energy. Okay, now power converter. Generally, what power converter that you are going to use for a specific power source, for that what you need to understand is first you need to understand what the power source is going to give me. Okay, the power source, it's a very crude. When you are taking oil from an oil field, you cannot take that oil directly, put in your vehicle and you can run it. Okay, what you need is you have to first process it. Before that you have to filter it. Okay, so here also the voltage that it is generating, as I have shown you in the characteristics, that voltage, power, these are flow dependent, and also based on your current level the voltage is coming down and all. You have to take care of these things. So no fixed voltage, current and power, and also it is flow dependent. So you need what? So output. Okay, output requirements are what? You are using it for, let's say, for grid connection or for islanded mode or for, let's say, your home. So what are the requirements that you have? It could be AC or DC. It could be grid connected, 3-phase, single phase, whatever it is. It can be standalone mode also. It can be in microgrid also. If it is microgrid, it could be AC, DC, micro, whatever it is. You have to connect it. So what you need is, you need a power converter. So you need a power processing unit. So the components of a power processing unit is, first and foremost thing is, you need filters. Okay. Now as I was mentioning about battery, in battery what happens? In battery, when you battery is a DC source. Battery behaves best when you take DC current or when you charge with DC current. Okay. So like this, here also, if it is a solar or if it is a fuel cell, these are not, you cannot charge it. Only thing is you can discharge them. Discharge means you can take power from them, current from them. It is best if you take DC power from them, DC current from them. Okay. So if you taking current which is having ripple, then it is better you use filter and filter it out, so that the current coming from the source is ripple free, or you minimize the ripple, so that the lifetime of the source will be improved. Okay. So that is why there is a necessary for filter, passive filters. Okay. Passive filters we prefer because passive filters are low cost and reliable. Definitely these passive things are reliable, apart from capacitor, because capacitor is one of the most unreliable component in any equipment. Okay. Then at the output also you need filter, because you generate, when it comes to power converter, we have bad name that power electronic engineers have a bad name that we are polluting the grid by injecting harmonics. Okay, we inject harmonics, but we use filters in order to reduce the harmonics. So use filters so that the load doesn't know whether it is coming from an inverter, PWM inverter, or it's coming from utility supply. Then the heart of the thing is power converter. Okay, that power converter could be AC, DC, 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 whatever it is. Okay, since it is a fuel cell, it definitely will be DC to DC or DC to AC. Now DC to DC converters are available. Okay, DC to DC converter, n number of research has been done and it's going on, still going on. So DC-DC converters are there, but when it comes to DC to AC, direct conversion is not there, or there are, but generally what we use two stages. One is, first you convert DC into suitable DC, and that DC you convert into AC using inverter. Then power converter comes with control unit, otherwise it will not work. A human body without brain won't work. So you need a control unit. Then you need sensing unit. Okay, you have to sense. We have eyes, ears, nose, mouth, skin. These are the sensing units. So here also, since it has to be a full system, it has to have a sensing unit at the input, at the output. In the input, I can say, like at the input, if you want to implement MPPT, the knowledge of current and voltage at the input side is necessary. Okay, that is why sensing unit. At the output side, you want voltage to be at certain level. So the power converter need to know at what voltage level I am generating. I have to correct or not. I need to make it correct. I need to make correction or not. For that you need sensing unit. Okay. Then protection, as he was mentioning, definitely when we do at academics, this thing we forget about, that protection unit is necessary, EMI filters are necessary, but in industry these things are more important, because an industry, first thing that they look into cost, second thing is reliability. Okay, so when it comes to a product, these three are the major thing that you need to look into. The protection, performance improvement using EMI, EMC filter and protection unit. These are far more important than anything else. Okay. And then communication. Okay. Now, when it comes to fuel cell, the things that we know that the output is DC in nature. It's a voltage and current, DC in nature. Voltage is low, current is high. Current should be ripple free or minimal to improve the life of the fuel cell, that I already mentioned. Power generation is flow dependent. That means if flow changes, then power generation will differ. So you need MPPT. Okay. Now here one question comes into my mind is, what should be the requirement? What should be the, now what kind of thing that you want to look into? Now you need, so you have fuel cell, now you got the fuel cell. Now you have to convert this fuel cell into, let's say you want to connect to the grid, or let's say you want to generate 230 volt AC for your home appliances. What you are going to do? What thing you are going to use here? How will you, what could be your idea? Just think what could be the solution? What is the first thing that you need? Okay, what is the gap? What is the gap? The power source is there, right? Now, what is the gap? You want to, let's say you want to run your television at your home. Yes.
The type of load we want to run.
TV I want to run.
Your DC. And what is the capacity of that load? Whether the input source will be able to supply or it is less or more. Accordingly, we have to control.
Yes. So the rating is important. Yes. Let's say the rating is sufficient to run your, let's say 1 kilowatt. 1 kilowatt is sufficient enough to run your measure of the home appliances. So what first thing that you will do with this converter, with this power source? What you are going to use? Any converter that you need to use, right? Power converter. So what power converter you want to use?
Depending on whether the load is DC operated or AC operated. If it is DC operated,
no, it's a television.
It should be fixed. If it is AC operated, then we have to convert.
So if it is a television, I mentioned, so that runs from AC. Okay. So in that case,
you have to convert it to AC. Then
see, it is you have to convert into AC. But the thing is, as I mentioned, this voltage is low. Okay, this voltage is 33 volt, and at home the voltage that you need is 230 volt RMS. So how we can convert them?
You have to first boost the voltage.
Boost converter. Yes, absolutely correct.
DC to
absolutely correct. Boost converters. Okay, correct.
Step up the DC voltage and then convert into AC.
Okay, correct. Absolutely correct. Now the thing is, here the voltage is 30 volt or 33 volt, and you need a voltage level of around 400 volt. Okay, there are many things that you can do. Okay, but I will tell you why those are not feasible or may not, you can avoid it. At home inverter, I don't know how many of have lifted it. Have you lifted anybody? Home inverter? It's a heavy inverter. Have you seen inverter? Because it is having a low frequency transformer. Okay, low frequency transformer we trying to avoid. Why? Because previously we had 5 volt DC sources, 5 volt adapters, where those were heavy. I remember we have at our home some music system. It is having an adapter which is very heavy, because it is having what this low frequency transformer. Now SMPS chargers that you have, that is mobile chargers, those are SMPS chargers which are low in weight because they don't have those kind of high frequency transformer. So why not to convert this 33 volt DC directly to some high voltage DC, so that you don't need any transformer. So normal boost converter to boost this voltage level to that higher voltage DC is not feasible. Just normal boost converter if you connect, that is not suitable. For that we need specific boost converter that I will explain. But before that, let me tell you, since it is high current application, since this converter is going to supply you high current, it is 30 ampere for a high power level, it will be more. So in that case, the current has to be distributed so that the reliability and efficiency can be improved. Let's say at the converter that you are going to use here is having 30 ampere, the inductor is at the input, you have an inductor, the inductor has to carry 30 ampere. Now if you split it into two inductors, the two inductors will carry 15 ampere each. So in that case, you can reduce the loss, you can improve the availability, reliability of the system. So because of that, the converters that we propose, so this I will come, the converter that is proposed here are, this is floating dual boost converter where, so this is one boost converter, this is one boost converter, this is another boost converter, so that it is twice, the gain of this converter is twice of boost converter. So we are trying to increase the boost, so that increase the boost value, so that we can increase the voltage output directly from the fuel cell. These converters are specifically, if you can see, state of art of DC-DC converter for fuel cell vehicles. So this is specifically to boost low voltage to high voltage, so that we don't need intermediate voltage, intermediate stages, and we can get higher output voltage, and we can generate the AC directly from the DC that we are obtaining. Okay, so the converters that we have here is, one is floating dual boost converter where we have two boost converter, and as I was mentioning about the inductors, two inductors which can share the current. So these two are, so these are boost converters only. This is one pair, this is another pair. These are interleaf boost converter where the ripple current can be reduced. I will tell you. So here two inductors will share the current, and also there is a ripple minimization technique by which you can reduce the current ripple delivered by this current source, by this source. Okay. So similarly, you have another which is floating double boost, double stage boost converter. So these converters are, so there are two stages, two stage boost converter, two stages, and then they are floating in order to make this. So they know that the output voltage of a fuel cell is less, and we need high voltage, and that is why we are using boost converter of higher gain, so that the conversion can be done without any intermediate stage, and directly you can convert into high voltage level, and this high voltage level you can use for conversion into AC. Okay. So there are different types of fuel cell, proton exchange membrane, and then direct methanol fuel cell, and these are the suitable. These actually all fuel cells are not suitable for standalone power generations. Okay, so there are specific fuel cell which are suitable for standalone power generation, and those are only we marked as suitable for distributed generation in case of microgrids. Okay, nothing comes free. Okay, everything comes with some. You cannot say that, okay, I made this and this is one of the best thing that we can have. It is not like that. Okay, everything comes with some issue. So it's first thing that we should associate with the fuel cell technology is it's expensive. Okay, it's very expensive currently. Okay, future maybe price may come down. Okay, but currently it is expensive. Okay. And hydrogen generation and storage is a difficult task. Okay, that's a very difficult task. And when you compare with other sources, you have to compare its, see, when it's a layman going to use your source, he doesn't know whether it is a battery, whether it's a fuel cell, whether it is a solar, whether it is a wind. He will compare whether like electric car and IC engine based car. When you sit on that, you don't think whether it is electric car, whether it is IC engine. You will see whether its performance is comparable or not. So here also, when you trying to compare it with other sources, there will be comparison of dynamic response. Its dynamic response is slow. Okay. So finally, we can conclude that it's a near future technology. Okay, people are working on it like anything, and in academics, research are going on, and research we do in academics, so that the things can be made practical and it can be made commercial. Okay, So suitable stationary and transport application, people have already started using it. Continuous power generation and supply to load, hence more desirable for distributed generation. Continuous, it's there, okay. Then PV and wind, it's a very intermittent in nature, PV and wind. So that is why we are looking for alternate sources, okay. Efficiency, we can say superior, we cannot say best, we can say superior. Carbon emissions are nearly zero. But this, what I mentioned in last slide, that converting low voltage DC into high voltage DC is a challenge. Okay, that's a challenge with more number of components, costly in the current scenario. Okay, so this is where I want to stop. Okay, a few references are there. So now I expect some question answers from online and offline participants. See, if it is 250 kilowatt, if commercially available 250 kilowatt, so it is either you use in islanded mode or it can be used for the grid connection mode also. Yes.